what's going on, guys? Welcome back. Today we are actually doing a Tryhackme learning path. So we've done this one for a while, the Soc Level 1. I haven't completed it for a long time now. Mainly, I'll tell you guys, the cyber security or cyber defense frameworks, I'm not going to do them all for you guys. Go through them. They're very easy to understand. Each of them are explaining a different way to do the same thing. And when I say different way, they're not showing you any technical details. They're showing you different frameworks that you can follow. I don't need to explain that to you guys. You guys can read that. The cyber threat intelligence, again, very similar. A lot of it, I covered some of it so that you guys understood it, but we're not going to go through every single one because they're all just different ways of doing things. We might do the YARA one because YARA is slightly different, but let's go ahead and get to network security and traffic analysis. So network traffic analysis. Now, the reason I'm covering this one specifically is because this is actually someone in my Discord just asked this question. They said, hey, I need to understand Wireshark. And they said, can you make a video on how to do Wireshark? Because I don't understand what I'm looking at. Well, what I try to explain to them is, even if I explain to you how to use Wireshark, you're still not going to understand what you're looking at. That's because you need to understand network fundamentals, right? So that's what we're going to do here. So the first thing is just talking about, there's nothing to actually do. I know this is gonna be a short video, but I'm gonna make a couple of videos a week on this till we get this path completed for you guys. That way we can just knock out Soc Level 1, especially because towards the end of the year, Tryhackme usually does different events and stuff, so I want to make sure we have time to try and do those as well. Okay, so there's some things that, like, different perspectives that people don't think about when they think about network security, and I think they understand it from a conceptual point of view, but not from a technical point of view, and that's what I want to talk about. So the essential concern of network security focuses on two core concepts: authentication and authorization. Okay, cool. Base network security control levels: physical, technical, and administrative. I bet you if you ask most people that went to school or whatever, like college or whatever, for pen testing, they're going to tell you this is where all the flaws lie, right? Because they're going to say, hey, the technical is where people have issues, right? Because that's where the vulnerabilities, the 0 days, all that stuff come. The reality is right here is where most of our flaws lie in a pen test. Why? Because people, see how it says right here, security controls provide consistency in security operations? That's true. But guess what? For every policy, there's an exception. For every access level, there's someone with scope creep. For every authentication process, there's a bypass, right? This is where your big flaws lie when you're doing pen tests, because people configure this piece versus technical. The system does what you tell it to. So unless a 0 day comes out or something like that, then it's as secure as the person setting it up, which is the administrative. So understand that. So there's two main approaches and multiple elements under these control levels. The most common elements used in network security operations are explained below. Okay. Main approaches: access control, threat control. Pretty easy, right? Starting point of network security is a set of controls to ensure authentication and authorization. Pretty easy. Access control. Then you have threat control, detecting and preventing anomalous and malicious activities on the network. It contains both internal and external traffic data probes. So anomalous being what activities are being monitored, right? We can set up access control, which just says, hey, only this person can do this. That's easy. That's super easy, right? That's black and white. But we also need to set up threat control where we say, hey, we notice something is a little weird. Let's look deeper into this, right? Access control is not going to tell us that, right? Now, a good example of this is, let's say you work over in, I don't know, let's say you work in IT, and you're working in IT, but you're accessing a lot of the HR files. You're trying to see if you're going to get that promotion, or you're trying to, that's going to let you hear as long as you have the permissions, but that's going to look really weird here, right? The threat control is going to be like, what the hell? Why is this person in IT who's never accessed these documents accessing all these documents this week? Then you put that together with some intelligence and say, oh, his bonus is getting ready to come up, or his raise is getting ready to be evaluated. Well, Probably makes sense. Okay, so now the key elements of access control. We have firewall, controls incoming and outgoing network traffic, right? These are predetermined security rules. These are things like, hey, I want 443, port 443. I want you to be able to communicate because you need to use the internet. Hey, I want port 4444 blocked because that is Metasploit's default port. Block it. It's that simple. It's black and white. Let these people in, let this person out. That's it. It's just a straight door, right? Then you have NAC, Network Access Control. This controls the device's suitability before accessing the network. So what's this mean? Hey, in order to be on my network, you have to have X, Y, Z. You have to have basically a VPN. We'll just say it wouldn't make a lot of sense if you're on my network, but let's say you have to have antivirus, you have to have EDR, and you have to have the image that I give you, right? Well, if you match that predetermined profile, you can connect to my network. Otherwise, you can't. That means when you come in my office and you plug into the port, nothing's going to happen because you're not going to be able to access the network. Now, you might get quarantined or something like that, but you're not going to be able to access anything, right? Then you have identity and access management. This is another big attack vector, right? Because this is where your passwords and stuff like that lie, right? Controls and manages the assets, identities, and user access to the systems. So this is where you're going to log into an application or whatever and give what permissions you need. Well, how do we get flaws here? Pretty easy, right? Because the system itself only does what it's told. It only gives me access to what I'm supposed to have access to. But what happens if you used to work in HR, then you transferred over to IT, now you work in legal? Did somebody go and make sure all those rights were removed, or do you have access to everything now? That's where the flaws lie, right? Look for the flaw in the system, not the flaw in identity and access management, because as a whole, it does what it's supposed to do, but we're looking for ways around it. Now, load balancing controls the resource distribution. This is pretty self-explanatory. It stops throttling and bottlenecking and stuff like that. It also stops you from being able to DDoS something technically, right? Even if it's on accident, because there is accidentals. Network segmentation. This is pretty self-explanatory. You take a network, you say, here's my critical assets. Let's put a little fence around them, right? Those are over here. In order to talk to them, you have to be very specific and a very special person. All the other assets are over here. So here's my special stuff. Here's my non, right? Keep them separate. It doesn't necessarily stop attacks, but it definitely slows them down. Now, VPNs, this most of you guys are familiar with. You probably have used them. This is simple. It's going to be you connecting to something, a proxy, whatever, connecting somewhere and establishing a secure channel. So every time you want to do something, it goes through that channel so nobody can see the traffic. It's encrypted the whole way. Now, zero trust model. Keep in mind, zero trust is exactly that. It's a model. It's not real. What I mean by that is you can never trust or never have zero trust, right? You just can't. If you did, your business would come to a halt. You'd be so slow. And that's why it says never trust, always verify. What do I mean by this? By your business would come to a halt? Well, let's say I have zero trust. What if your job, you're supposed to do some IT stuff, but every now and then you've got to do this admin task? Well, according to this, I should never trust you and always verify. Okay, so every time you want to do an admin task, you have to reach out to the security team or your manager or somebody to approve it, right? To verify what you're doing. Okay, sounds good on paper. Now do that across an entire enterprise, and you're talking about so much time wasted. What if your manager's not there that day? What if the IT person has 50 other tickets in front of them? This could take forever, right? So, really cool concept, really smart to think about, but keep in mind it's not possible to fully implement. You can do very well, you can get close, but if you want business to operate, it's going to be tough. Okay, IDS and IPS, intrusion detection and prevention. So this is exactly what it sounds like. It detects intrusion detection, and the other one prevents intrusion. So something like CrowdStrike can be an intrusion prevention system and detection, right? It's going to detect, hey, I think something's happening here, quarantine that machine, or do this, right? Now you have your DLP, data loss prevention. This is, again, looking at your sensitive data, your PII, your PHI, your PCI, your SPI, your everything else, right? And it's saying, hey, here's all my sensitive data. How do I protect it? Make sure it's not getting exfilled. How do I protect that nobody's accessing it? How do I make sure that it's safe, right? Endpoint protection, that's your machine. That's your computer, your physical computer. How do I protect it? Antivirus, anti-malware, DLP, intrusion detection, all that stuff. Then you have cloud security. This is exactly what it sounds like, your cloud security. So you have a cloud out there, whether you have an AWS tenant, a Google Cloud, GCP, whether you have Azure, whether you have whatever, Cloudflare, any of those stuff, you want to put some security on it, right? I would. That's going to be the first entry point, right? It's sitting out there open. So put something on it. That's your cloud security. And you can see data leakage is something very big. Data leakage happens a lot, and it's not intentional. It comes back to the person. The person setting it up didn't fully understand what they were doing. Now you have your SIM. This is Security Information Event Management. This is where you're going to actually get all of your information, right? This is going to correlate all your logs, and it's going to actually, you can set it up to alert you if you want, or you can set it up to do nothing, and you just have a log aggregator where you can query it and say, hey, I'm looking for Joe Schmo's account and see what he did on this date. However you want to do it. But the SIMs are very, very important, because otherwise you'd have to go to every single endpoint in the company. And if you have thousands of servers and workstations and everything else, it's going to take you forever to figure out what's going on if you ever even found it. Now, SOAR is a little bit, takes it a step further, right? Security orchestration, automation, and response. This could take it a step further. You can say, if you see XYZ with a SIM, right? You can say, if I see XYZ, do this, right? It's very black and white. It's very much like, if I see someone try to log in 15 times, lock that account. Very simple, very, boom. SOAR can do a lot more than that. SOAR can take something and say, hey, if I see some weird activity over here, do this, and this. And when I say that, I mean, it could be like, email me, quarantine the machine, disable the account. Like, it can do a bunch of stuff. So I can actually have run books in there that automate my defense, right? And then it also lets me know what's happening. So there's a lot that it can do. You can see it also adds vulnerability management, incident response, and security operations. So the SOAR takes the SIM to the next level, but the SOARs usually sit kind of like, I don't want to say on top of the SIM's not the right word, but they're integrated with the SIM. It's not the SIM itself typically. It needs the SIM still, because it has to have something that aggregates all that data, and that's where the SIM comes in. Now, network traffic analysis and network detection and response. So inspecting network traffic or traffic captures to identify anomalies. Pretty self-explanatory. You're analyzing the network traffic to look for anomalies. So all this said, right, go back to my example of Wireshark. If you saw all this, right, this is just the security features, right? All this stuff is the security features. So how are you going to look at Wireshark and say, here's what's going on? Right here, the network traffic analysis piece, right? Network detection and response. Look for anomalies. I say it a lot in my Discord live streams, and if you guys have not checked out the Discord, check out the Discord below. Also, check out the Patreon. They get a lot better videos is not the right word. They get a lot less Tryhackme, Hack the Box. They get a lot more like scripts I'm making, stuff like that. They get a lot more real world videos, and the reason for that is simple. I got to put a lot more time into them, so they get that because they're paying for it, right? So keep that in mind. They also get one-on-ones and stuff like that. So there's a lot of value down there in the Patreon. There's also my Linux course in there. So keep in mind this, looking for anomalies and threats, but I say it all the time, and I'll say it again, and that is all cybersecurity is patterns and anomalies. That's it. That's all it is. You find the pattern or the anomaly, and you find what you're looking for. All right, so you have your typical network security management here, right? You have your deployment. This is where you're going to initially deploy everything, right? This is your agents on the machines, your pre-configured security configurations for the machine, all that stuff, right? Now you have your configuration. This is where you're going to actually set that up, right? Your configuration, right? This doesn't just include the deployment of setting, putting the software in the machine or setting up a new firewall or whatever. This is configuring it. This is setting the actual settings of it, right? Then you have your management. Who's going to maintain it? Who's going to actually keep that thing up to date on whatever it is? Because maybe today, 443, every firewall allows it, right? But maybe tomorrow they come out with something different because it's too dangerous. Maybe, right? If that happens, someone has to manage it. Someone has to make those configuration changes, right? Then you have your monitoring. This is your system monitoring, user activity, all that stuff. This is where you're going to find the flaws, right? And then you have your maintenance. Your maintenance are upgrades, so new patches come out. You have your security updates. This is, again, patches basically, but they're just focused on security. Rule adjustment, so the example I gave before, the actual rule, who's changing that rule, right? That's the person maintaining it. Now the management, I actually misspoke on that. The management, they weren't talking about the maintenance, they were talking about the management. This is different. This is the configure or the policy implementation. So this is like setting up, hey, from a management perspective, here's what we're going to do. We're going to say, hey, we only allow XYZ ports on a firewall, and that's a policy we're writing down that controls all of this. When I say it controls it, I don't mean it physically controls it. That's where the maintenance comes in. Someone has to write those rules, right? But in the configuration, someone has to actually make that. But we're telling them this is what's going to happen. And if they don't abide by that, there's consequences. That's what the management piece is, right? Is making sure that these types of things are implemented from a higher level. Because if they're not, if there's just, we just kind of let people do whatever they want, you get issues, right? So now you have your managed security services. This is where, hey, we're hiring somebody to do certain things, right, for the security. So network pen testing. So this is most common what you see, right? You're going to see a lot of people hire external pen testers, come in, pen test it, blah, blah. Every now and then you'll get a vulnerability assessment. So this is, hey, we need somebody to come in. We're going to be held to a compliance standard, or we're now the compliance standard changes, or we're just evaluating things. We need you to come in and assess our system. Then you have your incident response. Hey, we have really good analysts, but we don't have enough analysts to do an entire huge incident, so we need to hire somebody out real fast. Then you have your behavior analysis. This is exactly what it sounds like. You're going to have somebody come in and say, hey, here's our normal behavior. What's our baseline? What does a normal person look like at this company, right? They do this, this, and this every day. Let's look for the anomalies, right? Okay, which security control level covers contain creating security policy? Which security control level covers contain creating? That's a weird way to word that. I'm not going to lie to you guys. Covers contain. Which security control level covers contain? Are they calling them? All right. So here is the, I'm looking for the exact one that they're looking for. Here we go. Network security control levels. So it'd be the administrative, right? Contain creating security policies. Yep. It's just a weird way to word that. It's like that contain doesn't need to be in there. It should be like which security control level covers creating security policies. I don't know what the contain's about. Okay. Now, which access control element works with data metrics to manage data flow? Well, let's go up to the access control element, and there's they are, and you say manage data flow. And here's your access control, and you're looking for data flow, right? There's your data processing flow. Let's see. There you go. Now, which technology helps correlate different tools, outputs, and data sources? Well, we talked about it. Oh, maybe we didn't. Which technology helps correlate different tools, outputs, and data sources? Well, let's find it. Oh, the SOAR. That was on me. The key there was the tool outputs versus data sources. Because, like I said, the SIM is going to look at data sources and aggregate. Tool outputs, it's probably not going to. You could probably make it, but all right. Now this one, this is actual traffic network analysis, and this is where we were talking about the Wireshark thing before. It doesn't help for you to be able to use Wireshark really well if you don't know what you're looking at, right? So here we have flow analysis. This is actually collecting it live, right? You're watching the flow, right? And Wireshark can do this. A lot of things can do this. Or packet analysis, like, hey, here's a packet that already happened. Can you tell me what's going on, right? And both are beneficial in their own ways, right? So does traffic analysis still matter? This is a question I get a lot, right? It's increasing shift to cloud computing, force attackers to modify their attacks, blah, blah, blah. Network data is pure, rich data source. It does matter. That's the long story of it, right? A lot of people say, like, well, AI can do this, da, da. That's true, but keep in mind, AI misses things a lot because what do attackers do? They try to make it look legitimate. It's the first thing they're going to do. So here we've got this site. We start the network traffic and we're watching. I know you guys probably can't see it all, but we see those red dots. Those red dots are the bad ones, right? We click restore the network. Not really sure why it makes you go through it twice. Oh, because we're now logging it. Apparently we weren't logging it first. Okay. Now analyze the data flow and enter the 2 IP addresses for the firewall to filter. Well, the first one I can see right here. This 4444, that is Metasploit's #1 port, right? So I'm going to take this, I'm going to copy it, paste it. I don't know if it added it. Okay, it did add it. Okay. And then the other one that looks odd to me is the 2222 and then the 7777, right? But let's see. Over here we've got some, so they're looking at the traffic analyzer. So here, this is what's the traffic showing. Here's the source and destination, I'm assuming, right? And then here you have the intrusion detection system and prevent corporate policy violation. Okay, so this is 16. Okay, we'll look at that one here in a second. I don't know what the policy they violated is, so it'd be nice if they actually did. Peer-to-peer usage, that could be weird. I wouldn't necessarily filter it in the firewall right away because it could be weird, but it doesn't necessarily mean it is. That could be weird. Social media usage, I don't care. Multiple login attempts. Again, they're being very vague because it's how many multiple login attempts are we talking here? Plus, that's the same IP anyway. Suspicious ARP behavior on 74. Where's 74? So I'm going to do 74. But the thing that's weird is, and I don't know what bad traffic is in their case, but you can see 56 is using a other protocol as well on port 8080. So we'll see. The suspicious ARP behavior is suspicious, but again, what are we even talking about here? Because it's going to 199. All of these are going to 199. Which is interesting. So I would say this one is the actual one that needed blocked, but we'll find out. Let's go ahead and add that, and let's see what happens. Now, does that mean it's going to fix it all? Nope, didn't fix it. So 62 and 99. Okay, let's try it again. I guess you actually got to pay attention to the packets. I didn't even pay attention to where they're coming from because 199 is the actual destination. Okay, so 62 and 99 are where they're coming from. Well, that's easy enough. I didn't think you had to actually watch the animation. That's on me. All right, 62 and 99. So just so you know, typically this will be destination, source and destination, excuse me. So this 199, this 99 definitely has to go. That was the first one we had. Because you can see it's got Metasploit on it. Okay. All right, you also don't get any feedback, which is interesting. And then 62, which was over here, was, it said, okay, so bad traffic apparently means malicious traffic. I didn't know that. All right, so there we go. That should be good. How's it still coming? I'm so confused. Oh, I did get it. That makes no sense. Why was it still showing the red traffic? What was the okay, I missed the flag there. Nope, didn't get it. Okay. I'll go back in the video and add the flag next. So this time, instead of IP address, just like 3 destination ports to block to stop the servers. Well, 4444 for sure. Right? 7777. I'm not even doing the analysis. I'm just looking. And I'll tell you, this may be incorrect, but it's very odd to ever see a port 2222 77777 or 4444. Could be wrong, but that's very odd. As we know, this means nothing. Okay, detection master. Okay, and I'll go in and get the second one. But that's actually, I know that seems super simplistic, but that is actually kind of how easy it can be sometimes. I've literally done analysis where I look at it and I'm like, obviously here's your problem, right? Because there's a port that makes no sense, right? There's typically, it's not that the port would make no sense. It makes no sense in the environment. So the better you know the environment, the better off. So for instance, if you're doing Wireshark at your home, let me get this pulled up here. And 62. All right, so if you were to do this in your home, you would see some ports that are, you'd pretty much know what you're doing, right? You might have, oh, I didn't get it. Let's say maybe you had a, I don't know, like a Minecraft server or something, and you have that port open, and then you have this and that. Okay, cool. You would know that. But then you see a random port, like 7777, and you just see that it's got traffic going to a weird website. It's pretty easy to tell that something's not right, right? Okay, so we just need 199. Oh, excuse me, it's 99. I did 199. And then 62. So traffic analysis can be very easy if you look for patterns and anomalies. When I say anomalies, you might say, well, where's the anomaly here? Look at every port in here. There's only 3 of them that are really odd, right? So focus on the odd ones. And then for patterns, right? Think about things like C2. When you have a C2 server, what is the anomaly or the pattern? It's calling back every 10 minutes, every 2 hours, whatever, right? That's the anomaly. Okay, I don't think I got it. So packet master, or was it packet capture? Got it. Okay. So long story short, this was just basic traffic analysis. I know I kind of ran through it, and I know there wasn't a whole lot to do here, but the reality is packet capture is your knowledge, or packet analysis is your knowledge of the traffic. What I mean by that is, if I come into your network and you hand me a packet capture and you say, hey, I need to find where someone got in, I can look for the anomaly. I can find, the weirdness, but you might say, no, that's just Jim. He does that. He runs that PowerShell script every week. Like, that's normal. How do I know that? Right? So your analysis is how good you know what's normal. And that's one thing that really AI is actually really beneficial for, and it has been around for a while in tools, but that's one thing that it's doing really well is you can give it enough time to learn what normal looks like, and it can tell you anomalies, right? So just know when you guys are doing traffic analysis, that's the very, very foundations of it. As we dive deeper into this SOC level 1 path, you'll see that we actually do investigate it. I actually didn't like that lab at all because it didn't tell you what you're looking at. Typically, it'll be destination or source destination, typically. And I think that's what it was. But it takes you a second to have to go, wait, what am I looking at? If you don't have just a title above it that says source and destination. It also, the traffic just says bad traffic. I don't know if that means malicious. I don't know if it means like there was flaws in the traffic, meaning like there's, network collision or what. I have no idea what's bad traffic to them. So things like that. But other than that, I mean, it was a good overview of what network and traffic analysis should look like, especially with the security piece. I definitely think you should go through those and make sure you understand each piece of that security, because it's really, really important when you're doing traffic analysis and stuff, what's expected. If you have an intrusion detection system, if you have antivirus, if you have scanners, if you have that stuff, that's all going to be traffic that's on your network that you should be aware of, because otherwise you're going to go, oh, that looks really weird, dude. That looks so weird, right? Does it? I don't know, right? If you guys don't know, some vulnerability scanners and things like that use Nmap as their underlying scanner. If you see Nmap in your environment and you're like, nope, looks too weird, maybe it's not. Maybe it's supposed to be. Maybe that's what your security team's running every day or night or whatever, right? You don't want to just block traffic just to block traffic. You got to know what you're looking at. So hopefully that helps you guys. Hopefully you guys have a great day. Thanks.